Hello everyone, this video is about the Gauss Seidel method. We start with the matrix vector representation of the system of linear equations. We can write it in the index notation. Now, if we take the elements where j is equal to I out of the summation, we can get to this iterative formula. And the method that uses this formula is called the Jacobi method. In this formula, previous iteration values are used for all variables in the next iteration. The Gauss Seidel method is a modified version of the Jacobi method. They allow using the updated values of x as soon as they are computed in the same iteration. And because of this change, Gauss Seidel method often converges faster than the Jacobi method. It is an iterative method, so the user must provide an initial guess of the solution. This initial guess is then used in the Gauss Seidel update formula to get the new values of x. Then we compare the new and old values. If they meet the stopping criterion, the algorithm outputs the solution, otherwise it feeds the value of x to the update formula for the next iteration. To implement this, we write Gauss Seidel function which takes the matrix A, output vector B, the initial guess x0 as the main inputs. The other two inputs are the maximum number of iterations allowed and the threshold value for use in the stopping criterion. On line 289, we start the loop to perform the updates as long as the iteration count does not exceed the maximum number allowed. On line 292, we find the updated values of x, and we can see that the values from the same iteration as soon as they are available are used in the update. On line 295, we check the stopping criterion. If it is met, we stop, otherwise we continue with the next iteration until the maximum number of iterations are reached. In the curve fitting example that we have seen in the previous videos, the coefficient matrix is not symmetric positive definite, which for the Gauss Seidel method is a sufficient but not necessary condition. This algorithm is known to converge when the coefficient matrix is symmetric positive definite or diagonally dominant. However, even if these conditions are not satisfied, the Gauss Seidel method may still converge but without a guaranteed result. Let's look at an example where the coefficient matrix is symmetric positive definite. We start with the initial guess x1 is equal to 0, x2 is equal to -1 and x3 equals to 2. In this case, the Gauss Seidel method converges to the correct solution in 3 iterations. In the next video, we will discuss the conjugate gradient method. Thanks for watching. I hope you like this video. Please subscribe and see you in the next video.